In this video, I want to give you a very short introduction on scripts. Now, it's just the first week when you have started working on your tutorials and started learning about finite element method, and I'm already jumping to this quite complicated topic called scripting. There's nothing to worry about there, but it's good to already know it from the beginning, so you have an idea of what you are capable of doing with all these commercial finite element programs. Of course, this part is not extremely important, but if you are interested, if you want to go deeper into the subject, especially with applications, then it might be a good idea to consider this as one of the things you want to start following, doing some reading about on the internet. Also, there are some good references that you can follow. Abacus and Patra Nashran also have their own manuals for scripting. So if you are using particular software and you want to learn a bit more about it, you will find more information. But through this video, I don't want to get into the details of scripting, but I want to give you a flavor of how it could be useful for you. So let's say, for example, that you are going to work on certain models, and in the education environment right now, you will be doing some tutorials. So you'll just work on certain models and then move to the next one, because you want to learn a lot of things and they're all going to be different from each other. But what happens when you come to an assignment? For example, you're in an industry environment and you have a problem and that you're trying to solve. So let's pick a relatable example, also a nice one, is that you have an optimization to carry out. You want to design a certain roof structure, for example. So let's just draw this particular roof structure as a very simple one. So I have some members which are vertical, and then there are some members that are at angles to each other, and I want to make a certain optimization or design of such a roof which is going to continue in the out of plane direction like that. But I'm going to just draw it in a way that you have only a 2D view, so only XY plane is visible. So you want to design it such that it's going to be able to undergo some kind of loading. So let's say you are staying in a hilly area and you have a lot of snow. So you want to make sure that the snow loads are taken care of. And of course, you're on top of a hill in an area where there's a lot of wind. So you also have some kind of wind condition. So you have a lot of wind on your structure, which is going to probably move it in this direction. So you have a certain amount of loading. You know that you have to design this structure depending on how much this load is. So you may have to carry out a number of iterations in your finite element analysis to come to the right design. And in terms of design, I mean what would be the cross-sectional area of each of these members. You could also consider what would be the materials that I want to use. So there are a lot of things that will keep varying throughout your analysis. Now, if you imagine that you would have to make 20, 30, 40, 100 different models for the same problem just to change a few things here and there, it's quite tedious. So what you want to do then is that you want to make a basic framework where you have the definition of your structure. So you have your basic boundary that is defined. So let's say you have your basic model here, which has all the geometry in it. Apart from the, let's say, the cross-sectional area that you want to use, geometry external we'll call it, and this would be linked with then other inputs. So you would have material input, you would have cross-sectional input, you would have load input. So all these things come in. Now we know that there are certain things that will always remain constant. So for example, I will have the geometry constant, I will have the load constant, but at the same time I have to optimize so that I have the best structure, most lightweight, the cheapest, etc., while finding out what would be the best material and cross-section to choose for this structure. So my basic program framework consists then of the geometry and the load. And what I'm going to add or keep changing is the cross-sectional area and the material. So I can create a small script which is going to define a material, many different materials. So I can have in a script material 1, 2, 3 and until material n. And I can have same way cross-sectional shapes. So if I want to go for rectangular cross sections, then I can take A and B, and I will have cross section 1, 2, 3 until n from B and A defined for each of these cross sections. And what I can do is on the basis of this basic model that I created, I just have to run my script so that it will load all the different materials and all the different cross sections. I can also make loops. I can say, okay, I want to check for material 1. I want to check all cross sections, and I will get results. And I can put them in a proper way which says, okay, if I have for material 1, for different cross sections, I want to find out what is the weight, the overall weight of the structure, and maybe that reduces or that increases depending on what I'm checking. And I can do the same. So I want to check for all materials. For material 1 to n, I want to check all cross sections 1 to n. So then I have these two for loops which is going to run throughout and get all the results. Maybe there'll be 20, 40, 50 curves which give me an idea that if I use a certain material, what would be the weight for a given cross section. And then I can choose my most lightweight design, which probably is going to be somewhere here. So that's a matter of scripting. So this is a very simple example, but it helps you to set up your model much faster. So if you have a really large model, like for example of an aircraft, and you have to use 20 different kinds of rivets, what you should do is you have a script which contains all the 20 rivets. So it doesn't matter what you want to model, you just run that script and all those 20 rivets are available to you. And you can just pick and choose and put the correct rivet in the right place. And the other advantage of using this script is that any model that you make which is graphical is quite large. And if you write it in form of a script, then it's just text, and you can save it as a text file, and you can share it with anyone you want. And if you comment it properly, people know exactly what you're talking about in your code, and they can run it on any software or any Abacus version or any Patran, whichever script you're making, to run the analysis. So they don't have to open this large database file which consists of all kinds of diagrams and pictures and all that, which is going to take a lot of space. So this is quite an easy way of setting up a problem where you're going to use repeated things. So in all the different programs, you will have it differently. So if we say we are going, let's first just look at Abacus. In Abacus, you will have there are different options. If you're using the commercial version, then what you do is you set up your replay file. So the moment you launch your Abacus module and you start putting something into it, you create a part, you put boundary conditions, etc., and you save it. In your work folder, you will see a .rpy, which is a .replay file. And this replay file is nothing but a collection of all kinds of commands that you have used during creation of your part. So this is all the basic lines of code that Abacus uses. So all kinds of keywords, etc., will be in this RPY file. It'll be in a different format. So it'll be written in Python using classes, substructuring, etc. So you can try and open it and see if you understand what it means. But it's quite illegible if you don't know the basics of scripting in Abacus itself. However, it's possible to do that with the replay file. Now, since all of you are using the student version, you will not get a replay file at all. So in that case, you will have to go around a certain method, and that would be to set up macros. So what you do is that you, when you set up a model, you have to create a macro. You rename it, and then if you keep saving it, all the lines of code that you're working out on your CAE will be stored in the macro. And this is one of the ways of setting up all the lines of code. But the macro is basically a function which is set up. So you will see that the syntax is going to be different than that of the replay file. Now you could also do something else. You can record your every session. That's also possible, and that basically means that if you are double clicking on something or you're clicking on something, it's also going to report those actions into those files. Of course, it's quite boring because it's a lot of information you don't need. So I would say stay away from recording a session, because then it really follows what you did. one by one, it's better to work with replays and macros. And these files can be easily opened in a text editor, and you can do your own editing into it, additions of loops, etc., to make changes to your code if you want to change some particular variables like cross sections, materials, etc. Yeah, so these are some files that will come handy to you when you are thinking about scripting in the future. Of course, in the current setup, we won't be doing much of scripting, but if you are interested, then we will pick it up in a practical maybe. If you're interested, you can put it on the discussion board saying we would like to have some examples in scripting and we would like to learn it. But please be aware that this is going to add extra workload for you. So we will have to compromise then with other things that we have to study. Or otherwise, I can put extra material on later on once you finish the course so that you can still learn this and get a grasp of scripting. The same thing sort of works with the Patran Nastran. So in Patran, what happens is you have a session file, and in the session file, everything is recorded. So all the lines of code, actions that you're working out will be recorded in the session file. You can also use any other programming language to set up the code, yeah, that you would be doing also on your own. So it's not so difficult to do. But basically, they both work in the exact same way. The difference is that all these programs have their own language that they follow, and they have their own keywords and their own classes and subclasses and lists. So there are some things you might have to remember. So it's best to work from a replay or a session file. So you have all the basic ingredients already in there. All you have to do is change certain things around them, creating loops or repeating statements or changing names of things. And that is much easier to do as a scripter than to actually go about writing the whole script on your own. So that's, in short, a small introduction to scripting. I hope if you're interested, you will put it on discussion board, and I can give you some good links of following some examples to go through this.